Welcome to AQA AS Redox Lesson 3. If you need to look at the textbook to help with this lesson, you need to look at page 160 to 163. The lesson objectives for this lesson are, first of all, to write half equations, and then to be able to combine and balance half equations. So for the first lesson objective, which is to write half equations, we need to go through a series of instructions. And the first one we need to do is to write the formula of the species before and after the change. So at this point we're going to use a very simple example. The first one we're going to look at is Fe2 plus going to Fe3 plus. So all you do is write a chemical arrow on the left hand side what it is before, and then on the right hand side what it is afterwards. So we're just writing Fe2 plus arrow goes to Fe3 plus. Once we've done this, you need to balance the number of atoms on the left hand side and the right hand side. And we're only looking at balancing the species which have changed oxidation state. So in some more complicated examples you'll have some other elements in there. Right now at this point we're just balancing the atoms that have actually changed oxidation state. So for this one we're just looking at Fe2 plus and Fe3 plus. So there's one atom of iron on the left and one on the right. So this one's already balanced, we don't need to do anything to it. So we can go on to the next stage. And the next stage is to work out the oxidation state of the element before and after the change. Now in our case it's really simple because they're only simple ions, and it's an Fe2 plus, so that's going to be a 2 plus oxidation state, and then on the right hand side we've got Fe3 plus, and that's a 3 plus oxidation state. If you can't remember how to work out oxidation states, then go back to the previous video, which is lesson 2 of the redox series, and that should help you remember how to do that. So we've worked out the oxidation state of the element before and after, so it goes from 2 plus to 3 plus. Once you've done this, you need to then balance the oxidation states. And to do this, all we do is add electrons to the side that's the most positive. So we've got 2 plus on the left and 3 plus on the right, so the right hand side in this case is more positive. To get from 3 plus to take it down to 2 plus, you need to add 1 electron, because 3 plus minus 1 is then 2 plus, so then you've got the same on both sides. So we've got Fe2 plus arrow goes to Fe3 plus and E minus. Now in this simple case we have now finished writing our half equation. For more complicated examples you might have to do some further steps. So I'll just briefly describe what those two steps are, and then I'll give you a more complicated example on the next slide. So if the charges, right now, if you look at that on the left hand side you've got a charge of 2 plus, and on the right hand side you've got a charge of 2 plus, because you've got 3 plus minus 1, which has come from the electron. So the charges are balanced on the left hand side and the right hand side, so we don't need to do this. But if the charges weren't balanced, then what you need to do is add H plus to one side of the equation to balance it. So you need to add H plus to the most negative side, either the left or the right, and that will balance the charges. Once you've done that, you might need to do the final step, which you might need to add some water molecules to one side to balance the atoms. Okay, so now we're going to try a slightly more complicated example, but the process we need to do is exactly the same. It's just that those last two steps that we didn't need last time, we need to do this time. So first thing that we did last time was write the formula of the species before and after the change. So this time we're going to look at NO3 minus on the left hand side and then NO on the right hand side. So we've just written out the two species before and after the change. Once we've done that, we need to balance the number of atoms on the left hand side and the right hand side of the species. And remember, at this point we're only balancing the elements that have got a change in oxidation state. So in this case we're interested in the nitrogen, so the nitrogen has to balance. And on our left hand side and our right hand side we've both got 1 nitrogen, so it's already balanced. The oxygen isn't balanced, but we don't need to worry about that right now because the oxygen hasn't changed oxidation state. It's 2 minus on the left hand side and it's also 2 minus on the right hand side. So we can go on to step 3, which is to work out the oxidation state of the element before and after the change. So hopefully you should be able to see on the right hand side the oxygen is 2 minus, so the nitrogen has to be 2 plus. On the left hand side it's slightly more complicated. If you remember, the overall charge is minus 1, so the oxidation states have to add up to minus 1. So we've got 6 minus from the oxygen because there's 3 of them and they're 2 minus each, so that's 6 minus. You've got to go from 6 minus to minus 1 So you need to add 5. So the oxidation state of the nitrogen and NO3- is +5. So the oxidation state of the element before is +5 and it goes to +2 on the right hand side. Okay, so the next step we need to do is to balance the oxidation states. And to do this, if you remember, we have to add electrons to one side of the equation to make it balance. So we've got +5 on the left hand side and +2 on the right hand side, so we need to add 3 electrons to the left hand side to make it balance. So the equation becomes NO3- plus 3 electrons goes to NO. Once we've done this, we need to balance the charges. Now we didn't need to do this last time because in a simple example we did on the previous slide, they'd already balanced. But this time, if you look on the left hand side, there's a 4- charge on the left hand side and there's no charge on the right hand side. So to make this balance, we need to add some H pluses. So there's no charge on the right hand side and there's 4- on the left hand side, so hopefully you can see that you need to add 4 pluses to the left hand side, and we can do this by adding 4 H pluses. So if you just add 4 H pluses, it then becomes 4 H plus NO3- plus 3 electrons gives NO. So all we need to do now is that final step of balancing the atoms, where we said that if you needed to, you could add water molecules to one side to balance the atoms. And to do this, all we need to do, we've got 4 H plus on the left hand side. The easiest thing is to look at how many H plus there are. There's 4 H pluses on the left hand side. So on the right hand side we need 4 hydrogens, and to get that we've got 2 waters. So there you go, that's all you need to do for that step. Okay, so now you should be able to write half equations. All you need to do now is to be able to combine and balance a half equation. So if you've got the oxidation half equation and the reduction half equation, you need to be able to combine them to give the full equations. And again, there's a series of logical steps that you need to do this. All you need to do, so first of all you write out the 2 half equations, which you should be able to do from what we've done on the previous slides. You then need to multiply the equations so the number of electrons on each side is in each equation is the same. You then add the 2 equations, and when you do this you cancel out the electrons on either side, which you should be able to do because in the second step you've made sure you've got the number of electrons being the same, and then if necessary cancel any other species which appear on both sides. The most common example of that is you might have water on both sides, or possibly H+. So the easiest way of remembering this is to do some examples. So I've given you an example here of magnesium reacting with acid. And as you should know from your lower down in school, when you react magnesium with acid, you get hydrogen gas given off. So first thing we need to do is write out the 2 half equations. So when you have magnesium reacting with acid, the magnesium starts off as Mg, so it's in a 0 oxidation state, and you end up with Mg2 plus 2 electrons. And the H plus is then you've got H plus electron minus gives half H2. Once you've got these 2 equations, the next step is to multiply the equations so the number of electrons in each is the same. So you can see on the first row for magnesium you've got 2 electrons. On the second row for hydrogen you've only got 1. So all you need to do is multiply that second line by 2 to give you 2 electrons for the hydrogen as well. So the magnesium stays the same, the hydrogen then becomes 2H plus 2 electron minuses goes to H2. Once you've done that, because we've now got the same number of electrons in both equations, all you need to do is add those 2 equations together and making sure that you cancel out the electrons on either side. So this then becomes, everything on the left hand side of the arrow would be Mg plus 2H plus. You don't include the electrons because they cancel out, and then you've got an arrow, and then you've got Mg2 plus H2, and again you don't include the 2 electron minuses because they cancel out with the left hand side. In this case we don't need to do anything further, but it might be that you had H plus on both sides, or if you had water on both sides, in which case you'd cancel out any other species which appear on both sides. Okay, so just to remind you of what you should be able to do after having watched this video, our lesson objectives were to write half equations, and then also to then, once you've written the equations, be able to combine and balance the half equations.